Hello students, welcome back once again. Today we shall discuss about chapter number 5, states of matter. First of all, we will discuss about intermolecular forces. Attractive intermolecular forces are known as van der Waals forces. It includes dispersion forces. It is also called London forces, dipole forces, and dipole induced dipole forces. So students, here we are mainly focusing on interaction between molecules. So far we have been discussing about how atoms combines to form molecules. Now we are mainly giving focus to how molecules interact each other. Let us discuss van der Waals forces in detail. Van der Waals forces are of four types: London or dispersion forces, dipole interactions, dipole induced dipole forces, and hydrogen bonding. We shall discuss the first one, that is dispersion forces, in detail. The force of attraction between two temporary dipoles is called dispersion force or London force. Students, atoms and nonpolar molecules are electrically symmetrical and have no dipole moment because their electronic charge cloud is symmetrically distributed. But a dipole moment can develop momentarily for an instance even in such atoms and molecules. Suppose we have two atoms A and B in close vicinity of each other. It may so happen that momentarily electronic charge distribution in one of the atoms, say A, becomes unsymmetrical, that is, charge cloud is more on one side of the other. These forces are always attractive. The interaction energy is inversely proportional to the sixth power of the distance between two interacting particles, that is 1 by r raised to 6. The force is available for short distance of approximately 500 picometer. Its magnitude depends on polarizability of the particle. The electrons in the 1s orbital of helium would repel each other and therefore tend to stay far away from each other. They occasionally wind up on the same side of the atom. The helium atom is polar with an excess of electrons on the left side and a shortage on the right side. If another helium is nearby, then would have a dipole induced in it, as the electrons on the left side of helium atom to repel the electrons in the cloud on the helium atom 1. These forces are present in all molecules, whether they are polar or non-polar. The tendency of an electron cloud to distort in this way is called polarizability. Students, here you could see the temporary dipoles induced in molecules. This force of attraction was first proposed by German physicist Fritz London. Next we have dipole forces. The forces of attraction in the molecules having permanent dipole moment is called dipole forces. The positive end of one is attracted to the negative end of the other and vice versa. So children, in dipole forces, there will be a permanent dipole moment, means already the molecules will be polarized. The interaction between any two opposite charges is attractive, and the interaction between any two like charges will leads to repulsive forces, as you can see in the figure. The interaction energy is inversely proportional to the Distance between polar molecule. Here you can see different molecules which are polar in nature and having different dipole moments. As the dipole moment increases, what happens? The boiling point is also increased. Why? Because the more polar the molecule, the higher will be its boiling point. Why? Because the attraction between the molecules will be more. Because of that, they will not easily dissociate and boil out. Okay, that is the reason. Next, let us discuss about dipole-induced dipole forces. The attractive forces occurs in the polar molecules having permanent dipole, and the molecules lacking permanent dipole is called dipole-induced dipole force. The interaction energy is inversely proportional to the sixth power of the distance between two interacting molecules, that is 1 by r raised to 6. Finally, we have hydrogen bond. The dipole-dipole interactions experienced when hydrogen is bonded to the electronegative elements such as nitrogen, oxygen, fluorine are usually strong. These interactions are called hydrogen bonds. Here you see hydrogen bond formed between HF molecules, then NH3 molecules as well as H2O molecules. Energy of hydrogen bond varies between 10 to 100 kJ per mole. Hence, hydrogen bonds are powerful force in determining the structure and properties of many compounds. Next we have thermal energy. Thermal energy is the energy of a body which is created due to the motion of its atoms or molecules. It is directly proportional to the temperature of the substance. It is the measure of average kinetic energy of the particles of the matter. It is responsible for the movement of particles, which is called thermal motion. Children, simple words we can say that the energy which is created by the movement of molecules. Whenever temperature increases, of course the molecules will have a higher kinetic energy and they will collide each other. That collisions can lead to the formation of heat energy or thermal energy. Now let's see intermolecular forces, how it affects due to thermal interactions, or we can say that intermolecular forces versus thermal interactions. Three states of matter are the result of balance between intermolecular forces and thermal energy of the molecules. Intermolecular forces keeps molecules together, but thermal energy of the molecules separates them. Intermolecular forces increases from gas to liquid and then liquid to solid, whereas thermal interactions, when we see it actually just opposite of intermolecular forces, where thermal interactions will increase from solid to liquid and to gas. So students, gaseous interactions as well as gaseous states along with the gas laws we will be discussing in the coming modules. Thank you and have a nice day.